Hi, welcome to the Air Manager API tutorial video series. In this video we're going to start looking at hardware. So the hardware we're going to look at in this video are for the button, the LED, the switch and the rotary encoder. We'll cover the other elements of hardware in later videos. So the first thing to say about hardware is all of the hardware refers to the actual hardware interface, the pins of the device that you happen to be using with these hardware IDs. And there's a link here on the API page to that hardware list, which we'll have a look at in just a moment. But you can see here where it mentions HW_ID, hardware ID. That's referring to this hardware ID. Don't mistake that for the ID at the beginning here. This is the ID that we use to give a reference to our function, just as we've done with lots of the other functions that we've covered already in the video previously. So this hardware ID with inside the brackets here refers to the hardware ID, i.e. the pin that you're saying that you want to connect to perform this particular function. So let's have a look at the hardware ID list. Okay, so you can see here a list of different, lots of different devices here. For the purposes of this demonstration, I'm going to use an Arduino Uno, but you can use any of these pieces of hardware. And it does actually say at the very beginning there, note that the instrument must run on the platform to have access to the hardware I/O. So that basically means that you need to have your hardware I/O, i.e. your Arduino Uno in this case, plugged into the computer that will be running the instrument that you've got the hardware code that you're going to develop on. So that means if you have it on Air Manager, then it needs to be plugged into the machine that Air Manager is running on, and equally if you have it, if you're intending on running it on Air Player, you're going to deploy the code on Air Player, then the Arduino needs to be plugged into the machine that is running that instance of Air Player. So whether that be a Raspberry Pi, you could plug it into the USB of the Raspberry Pi, or just another Windows machine that's running Air Player. The particular hardware needs to be plugged into that machine. So important note that a few people have come a cropper with that. Not recognizing the hardware not being recognized and not actually functioning, even though the code is perfectly okay. So here you go down the different devices there. We're going to scroll down to Uno because that's the one we're looking at today, but you can come back to the page here and peruse this list at your leisure. And you can see here that the different types of hardware that we can interface with are listed across the top here, and then all the different pins or I/O, separate I/O lines for the Uno are listed here down the side. So the analog lines there and the normal I/O digital lines here, and it just gives you a cross-reference table of what's possible. So we never use 0 and 1 on the Arduino because they're used for communication. That's what it uses, those two pins to communicate with the host computer. So we never connect any hardware to those pins, and then all the rest are pretty much, as you can see, free. You obviously can't do ADC analog input unless you're on one of the analog lines, which is why these are ticked, but all the rest are pretty much free to do as you wish. You can see PWM on the Uno is only available on D9 if you need to use PWM. So that just gives you a flavour for which ones are available. So we're probably just going to use these lower side ones today, just because they're conveniently located and easy to find. You'll see what the setup we've got in a minute, just a minute. So let's go back. So these functions are all fairly straightforward, as you can see here. Most of them are one, at most two functions for each one. You can see for the button, literally all we do is add the button, and then you can just operate the button, and it will operate with some code to read the button back. It gives you a callback here whenever you press or release the button. The LED, again, you can set the LED up and just use that if you wish, because you can give it the initial brightness. If you're only ever going to turn the LED to be a certain brightness on, then you just use the add. But then obviously there might come a time where you either want to dim the LED down or you want to turn it off altogether, and that's where you use the set function. So you initially add the LED and then you set the status of the LED using this function here, and you vary the brightness between 0 and 1, as we've seen with some of the other functions. So 0 being off and 1 being full brightness. Switch, again, very similar. You add a switch with the add function. You can give these, you can see it's got this hardware ID _n there, meaning that you can add as many of those you have switch positions. So I'm just going to probably show you a three-way switch today, so we would need 3 different hardware IDs from our list that we just looked at for that, for the 3 different connections on our three-way switch, and then a callback which essentially just returns the position that the switch has been rotated to. And then an additional function here that if you want to, you can interrogate using the hardware switch ID, which you give at the beginning of the function of the add, and that will return the position of the switch. So if some later time in code you wanted to check the position of whatever that switch was, you could just read that back into a variable and get the position of the switch based on that hardware switch ID. And then lastly, the rotary encoder. Again, it's just a simple add. You add the rotary encoder, you tell it the A and B connection pins, so you need two hardware pins for an encoder, and there's a callback at the end. So as you rotate the encoder, this callback will return a value back to that function, and you can act upon that value that's fed back, and it gives you which direction it has actually traveled. So it'll give a callback for every click, so you can basically adjust your code accordingly and perform whatever function you want that encoder to do. So it might be, increasing a frequency or turning a heading dial. Lots of different functions you could use with a rotary encoder. So let's get stuck in to the code window. So we have the usual code window up here. I'm going to start off with the button first, and we'll work our way through those 4 particular hardware items that we spoke about at the very beginning. So what we've got here, let me just turn this on so you can see. In fact, what we'll do first is we'll go to the devices tab, and I can show you where the hardware appears. So when you've flashed your Arduino, so it's important to note. Let me just bring that up quickly because we didn't really cover that. If we go back up to the very top there and go to the main wiki page, you can see here under hardware here there's an Arduino link. If you click on that Arduino link, you can see here there's instructions and an installer and a download for that installer there. There's also a little bit about the message port that we'll get onto in a much later video. So we're just basically going to download and use the installer to flash our Arduino. As part of that program, that installer program, you get to choose what Arduino you have. So in this case of today's video, I would have chosen Uno, but if you have a Mega or a Nano, you choose the appropriate one, and you choose the port, the device ID, if you like. Let's remind ourselves what it's actually called. So you see this little A here. So you have lots of characters that you can choose, so you can have multiple Uno, so you could have an A Uno, a B, a C, a D, etc. So you get, when you flash it, you get to tell it if it's an A, a B, a C or a D as part of the choice of that. And when the flashing is complete, all you need to do is come to your computer and plug it in. With Air Manager running, it should recognize. So you can see here I've got a couple of devices. I've got a Knobster that I was playing with the other day, and an Arduino Uno. They're grayed out at the moment. You can see they're sort of grayed and not showing bold there, because they're not actually connected at this moment in time. If I was to shut down Air Manager, then I think the Arduino would probably disappear. So it takes about 20 or 30 seconds for it to recognize. So what we're going to go ahead, before I do that, I'm just going to show you what we've got here. So if I just turn the camera on, so what we've got here is we've got an Arduino Uno connected up to just a little bit of breadboard here, and we have a USB connection which I'm going to plug in a minute and show you. And I've just connected the initial connections, which I'll explain in a minute, for the little push button here that we've got for the purposes of this first demonstration. So let's go ahead and plug in the USB connection and just watch that Air Manager window there for a minute. It's still grayed out at the moment. As I said, it takes about 20 or 30 seconds for this to appear here after we've plugged in. We'll just give it a few seconds. There we go. So there our Arduino Uno is now recognized. It's not grayed out anymore, and we can click on that and it will say there channel was the terminology I was trying to think of. So the channel is the bit that you can select when you flash the program. So that's A or B, whatever you want it to be. And the state here connected. So we have our hardware connected, which is great. So we can go back to the Create Edit tab now, and we can look at the code that we've got that we're going to program now. So just before we do that, I'm just going to explain what we've got here with the Arduino connections. Let me grab something so that I can point out what we've got here. So the first, we've only got essentially two connections here. We've got the white wire here, and we've got the black wire here. So the black wire here going into the Arduino here is going into one of the two ground pins on this side of the board. Okay, and I'm bringing the ground connection over to the breadboard here, and then I'm using another black wire here just to show you that it's ground to connect to the same point there, and I'm bringing a ground up to one side of the switch here. And then the white wire is connected to the I/O pin D2, okay, this location here on the other side of the Arduino board, and that is coming up to the other side of the switch here. You just can't see it, just out of shot there, just hiding behind this black wire here, but there's the white wire connected to the other side of the switch. So essentially you just need a push button switch or a momentary switch, one side connected to ground, the other side connected to your pin on the Arduino, and this is the statement that we looked at earlier on the wiki page. So I'm going to give it a hardware button ID because we get in the habit of using the ID even though we're not going to use it in this particular bit of code. The hardware button add, I'm going to tell it which hardware ID I want to use. So that hardware ID being from that list that we looked at when we first started a video. So the format here is Arduino _ Uno because it's an Uno that we're using. It's channel A from our devices tab over here, and then D2 is the pin that we've got the white wire here connected to, D2. And then two more arguments. The first one, the callback for the pressed condition and the callback for the released condition. So when the button is pressed, it will call back whatever that function name is that you put in there. I've called it button pressed. There's my function, button pressed. and then there's the other one, button released, function button release. So all we're going to do when we press the button here, just for the purposes of this demonstration, is just to print the words hardware button pressed and hardware button released as we release it. So let's go ahead and run our instrument and see how we get on. So there's the instrument, but there's that you can see now with the hardware. Obviously we're not adding any graphics, so it's just a completely blank instrument there. So there's not much to see, but from a hardware perspective, there's our Uno. There's the push button. So when I push press now, if you watch the console window here, you'll see the words come up here. So we push press and it says hardware button pressed. I've still got my finger on that now, so it's not actually going to do the release yet until I let go. And then when I let go, we get the hardware button release. So press, release, press, release. You can see very responsive. You can push it as many times as you like, and you get the press release each time. So I've just rerun that instrument now just to clear the console down so make it a little bit easier to see. Now, one of the other things that happens with the hardware items is you get a list of the hardwares that you've added here as part of your code, because this, at the moment in this code we've only added one button, so you can see just a button appearing here. But if you had added lots of different elements of hardware, you should see them appear in this hardware tab along here. Now, if your instrument had lots of other code in it too, you might also see other tabs along here for, you know, subscribes. If you're using you probably will be using some subscribes in your instrument to get some data out of the sim. So for explain, you will see explain or whatever it is across the top there, as we've seen in some of the other videos. But this also gives you a soft way of testing your code. So that button there, without necessarily worrying about or wiring up that switch, I can still run the code by just pushing this soft push button, and it should give me the same result. So let's go ahead and do that. So push, I'm still holding the mouse button there as if I was doing holding a real button down. So you can see it says hardware button press there, and then when I let go, hardware button release, and again button release on, off. Just the same as if you were using the real hardware. So handy for testing, but that's obviously only testing the code, so you can get your code right without you having to connect all of this up here. Okay, so that's button. Next we're going to look at LED. So we've been away there and just reconfigured a little circuit now, and so we've set up for looking at the LED. So you can see I've got in the code window here the example that I'm going to show you for LED. If you remember when we looked at the wiki page earlier, the LED had two functions associated with it. The first one was the add, and then the second one was to do with setting the brightness for the LED. So with the add, again, you just had to add the hardware ID. We've chosen D3 here, so let me get my little pointer again and show you that we've got a yellow wire now in the D3 location down here at the Arduino board, and that's coming over to the anode of our LED here. And then the cathode side of our LED is connected to this resistor here, which goes down to ground at this end, and that's connected to this this common ground line along here, where our ground black wire goes back to our Arduino. So we're connected to D3. Initially I've got this commented out here, and I've got this little timer which I'll explain in a moment also commented out. So you should see that when we fire it up, because I've got the brightness set to 1, which should be full brightness now. When we run the instrument, we should see our LED come on, and there you go. The LED is on there. Looks very, very bright in the little image that you can see in the video here, but it's actually an orange color LED, and it's lit up quite nicely. So what we'll do is we'll uncomment this hardware LED set now, and we'll change the value. You can see I've got a value in there of 0.1 0.05, so very, very small. And the reason I've chosen a very small value like that is just so that you can actually see the effect. Rest assured, it's very dim here when that value is in, but the camera is obviously picking up. It's very sensitive to the light, and it actually still shows as quite bright, even though you got it set to quite a dim level. So I've gone very low there just so you can see on the video, and you will see a little bit of pulsing. That's the dimming there that you can see, but in real life there's no pulsing. Your eye can't discern that frequency. It's just the camera that's picking that up. It's actually just a much dimmer version of what we saw before, but you can see the general effect there. It's much less light output from the LED there, with the view that you have there in the little camera, and so what we can do is we can change that value back up to, and you'll get an idea for what I was trying to say 0.2, and we rerun the instrument. You can see it's you know, a small effect of that dimming there still a little bit. See, it's a little bit brighter, and then we'll go all the way up to 1, and there you go, nice and bright again. So that's the two LED functions. Fairly straightforward, really. The add, and then you can manipulate this LED later on with a different value. Now, the other thing to say as well, of course, you can send it a 0, and if you send it a 0, it turns it off completely, as you can see there. So that leads me on quite nicely to what we're going to do here with the little timer. So essentially, I'll uncomment this now. This little timer runs every 500 milliseconds, and essentially we'll just toggle the state of the LED. So I've got this little statement in here that will basically say if the LED is already 1, then make it 0, else if it's not, it will make it 1, and then we're just going to use that hardware LED set function to use the hardware LED ID that we created here, and then give it the LED state, which is the name of the variable that we've used for this little statement here. So it'll either get a 1 or a 0, and it'll just keep toggling between 1 and 0 backwards and forwards every 500 milliseconds. So that will give the effect of a flashing light. So similar to what we did with a soft image, where you could flash a graphic up on our Air Manager instrument, you can now actually do that with a real bit of hardware. So let's give that a go. And there you go. There's our LED flashing on and off at 500 milliseconds, and just so that you can get the idea, we can slow that down a little bit. Now it's only flashing at once a second, or changing state once a second now. So on for a second and off for a second. And another good way, because the LED is obviously an output device, not an input device like a button, if you wanted to test the LED, you would obviously have to connect it up to see if it was working, because you still have this function. You can see here also the status is being reported up in this hardware tab again. You can see now, because it's toggling on and off, it's saying 100%, 0, 100%, 0. As we selected those different values, you would have seen the percentages appear up there. So that's giving the status back of the output of the code there, of what the code is doing. So you don't have to similarly with the button connect the wires again. You have almost like a virtual LED there, even though it's just not something you can physically see in terms of the light or the brightness. You're getting this reported value back, and again, that's only giving you the functionality of your code to, while you're developing your code, you can test and see how that is working. So we're going to take a pause again here, and we're going to get set up for what's next? Switch. We're going to get set up for switch. So here we are set up for switch. If I just explain very quickly what I've got set up here, and then we'll get into the code function. So we're simulating a 3-position switch here. So what I've got again is I've got my ground connection still in the same location on the Arduino, coming over to the breadboard here, and then along the common ground connection I'm using this flying lead here as the common for the switch, if you like, and I'm just going to move it to these 3 separate positions. So I've got 3 separate positions here. One is yellow, that's my position 0. Green is my position 1, and then the last one at the far end here is the white one. They're going into I think it's 5, 6 and 7. Yeah, so the yellow one is in 5, the green one is in 6, and the white one there is in D7. So what we've said here in our code is we've said same thing, hardware switch ID. We've created the ID for it. We've said hardware switch add. Then we're going to give it the 3 pins. So this, because it's a 3-position switch, this now needs 3 I/O pins to operate. So we've said D5, D6, D7 are the 3 pins that we want to use, and you give it the order as well. So the first one will be 0, the first one will be, the second one will be 1, and the third one will be 2, if that makes any sense. So 0, 1, 2. That's how it reports back in terms of its position. So you have to put these in the order that you want those responses to come back. And then after you've given it the number of connections in for your switch, you give it a callback name on the end. So again, I've just called it switch callback, and you can see I've created a switch callback function up here. Now what it returns, you can see here I've got POS, short for position. It returns the position that the switch has been set to. So whenever the switch is rotated or moved or changed, its status has changed from one connection to another, and that is basically done by switching the ground. So you connect the ground to the common of your switch there, and you switch the ground to either of, in this case, the 3 connections, but it could be a 12-way switch, in which case you'd have 12 separate hardware IDs in here, and rotate that switch around all of the 12 positions. And your POS there would then be from 0 to 11. That would be your 12 positions. So what I've got just in this function very quickly then is just print the words switch position is, and then just append on the end of that the actual position information. So it should say switch position is 0 or 1 or 2. They're our 3 positions. Now down the bottom here, I'm also showing just a quick line, one of the other functions that when we looked on the wiki page at the very beginning, one of the other functions associated with switch was hardware switch get position. So you can at some later point in your code get the position if you want to, but for this purposes of this, when this runs, it's going to do that that callback, and it's going to run this position, but it's only going to do that once. The callback will work every single time, because every time you move the switch, whereas this is only just in our main code here, and so this will just run once at the very beginning because of where I've got it. But it's just to show you really that this hardware, you give it the hardware switch ID which you refer to here, and then it will just get the position based on whatever switch is associated with that hardware ID. I'm just printing it to the screen, but you could use a variable name equals at the beginning here to store that switch position into a variable, and then do something with it later on. So that will be the same information as you're getting in this POS up here. That will just be a number 0, 1 or 2. So let's just go ahead and run that and see how we get on. So at the moment I've got my switch in position 0, so the black is connected to the yellow. And you can see it's reporting here 0 because we're in position 0, so that's this function here that's printing that 0, and then we're getting the callback that says switch position is 0. So switch position is 0 because we're in position 0. So let's go ahead and move it from position 0 and go to position 1. There you go. So now we're in position 1. It says switch position is 1. We take it out of 1, we go to 2. Switch position is 2. Is 1. Is 0. So you can see there, every time you basically move that ground connection as if you was rotating a rotary switch, or you could be using, I've got a little switch here, you could be using a switch similar to this here. This is just a toggle, let's get it, there we go, toggle switch. So it's just a simple toggle switch, and you have 3 connections on the bottom. So the middle one is your common, and then the other 2 are used for the 2 different switch positions. So that could just be a simple 2-position switch that you might want to set up, and every time you toggle that switch one way, it'll either report 0 or 1 for the 2 positions of that switch. So for switch, really simple and straightforward in terms of how that operates. We'll take another pause now, and we'll get set up for the encoder. That'll be the last one. So here we are again on the last one for this video, which is encoder. So if you remember from the very start of the video when we were looking at the API page, we had hardware dial, so it refers to the function as a dial. So we use the hardware dial add after setting up our hardware dial ID, of course. And then we just, because the encoders use an A and a B connection, so you need 2 pins for that. So I've chosen D8 and D9 for that purpose. And then as part of the hardware dial add function, if we just come back to the API page here, you can see that the basic form of the function, just you specify your A and your B of your encoder, and you can just call the callback straight. But you also have the option to use these other arguments, which are optional, and they are type and acceleration. Now I would urge you to use them, because it means that you, well, not necessarily acceleration, but certainly the type one, it forces you to learn about your encoders and to understand what type of encoder you've actually got, rather than trying to drop back to what that default might offer you, and that may not give you the result that you're looking for. So if you want to understand the different types of encoder, you can jump on the internet and read about the different types of encoder. I think I've even posted some things in the forum about the different types of encoder, but it's to do with the number of pulses that the encoder will give out in relation to the number of detent positions of the knob when you rotate it. So the types are 1 detent per pulse, 2 detent per pulse, and 4 detent per pulse. So I'll show you when you select the different ones of those what the result that you get back out of Air Manager is. Obviously if you've got the wrong one selected, you won't get the appropriate result. Acceleration will give you, if you have a read of what it says here on the API page, will basically give you more callbacks if you rotate the dial faster. So that you know, for those functional requirements where when you start to rotate the dial, you want it to start accelerating, because you're trying to go up a long way. So for instance, you're moving your heading dial and you're coming right the way through 180 degrees, or you're whizzing right round, and you don't want to just keep turning it and turning it and turning it about 7 times just to rotate that thing. As you start rotating it a bit faster after the initial thing, then it should just call a few more callbacks and jump a few more degrees a lot quicker, similar to some other functions on some other avionics that also perform that way. So it gives you the option to be able to add that acceleration in straight in the add there, by giving it a multiplier number, so you can play around with that and specify what number you want, and that will call the callback function that the encoder calls more times, more frequently, as you rotate the encoder faster. So let's go back to our code window. So that's what you see here in this code example that I've got here. I've got all of those arguments here. So I've got the A and the B, which is D8 and D9. I've chosen the type 1 D10 per pulse because that's the type of encoder that I've got here. But I'll show you what the other two, the kind of result you get if you select the wrong one. And I'm not actually sure what the default is, so we can you can probably have a play around with that. You may find that, you know, if you don't specify this, it will have to default. If you don't specify, it will have to default to one of these. So I'm not sure which one it is that's set up, but if you've got lots of encoders that are of that type, then I suppose you could omit this argument and just leave it blank, because the default would work for you. But I like to put it in just so that if nothing else, when you're looking at your code, you understand what type of encoder that you're actually trying to operate with there. The acceleration I've set for 1, just for the purposes of just to show you where it goes and in what order in the statement here, but you can play around with that number to adjust the number of callbacks. And there's the callback itself. So we've called it dial callback. The dial callback's up at the beginning of the code here, and then we'll talk about that in just a moment. And then we've got which you've just seen actually in this very video, hardware button add. So because this particular encoder, as do a lot of encoders, has got a button. You push the shaft in and you get a little click button on the encoder there. So sometimes you find that encoder button has got an action associated with it. So just for the purposes of this, even though it's not related directly to the encoder because we've done button already, but just to show you how that comes out on a separate pin of the encoder if they have a push button, and you treat it just like a normal button. So a hardware button add, you tell it the pin that you're going to connect that switch pin to. In this case it's D2, and you give it a function name, button press, just like we did before. Now I've not put the released in here because it's optional. You don't have to. I didn't mention that when we looked at hardware button add, but you don't. Similarly, how you don't have to have the released for this soft manager buttons that we looked at in previous video tutorial. You have to have a pressed, because obviously you have to press the button, but you don't have to have a released if you don't want to. But you can, of course, put that released one in there if it's important to you to know when the button released also. So I've just got a little function up here that's set button pressed, and it just prints encoder button has been pressed whenever we press that button. So getting back to the dial callback then, when you rotate the dial, the function, the hardware dial add function, the callback basically returns the direction in which the dial has moved, or the encoder has moved. So it will return a 1 or a -1 depending on if it's clockwise or counterclockwise. So what we've got here is just some if statements there that basically saying if that direction is 1, print the word clockwise, and if it's -1, then print counterclockwise. If you have the direction, well, we'll do it in a minute, the direction the wrong way, there's a way of correcting that fairly easily, or you can just change it in code. It doesn't really matter too much, the A and the B, as long as you get the it the right way around for how far you want the particular instrument to work. So let's go ahead and run this. Oh no, before we do that, before we actually run, I just want to explain very quickly how this is connected up. It is particular to this encoder, so not all encoders will have the same sequence or connections, but they will have a similar set of connections, so it's important to talk about what we've got connected here. So we've got a power and a ground this time, so you can see I've still got the ground wire in there, my black one here, and this time the black one is coming over directly and connecting to the ground terminal of the encoder. So this particular encoder is mounted on a little board at right angles, or should I say the board has got a right angle header on it, and I've got it pushed into the breadboard here. So one of those 5 pins, I think it is, along the edge of the board there, one of them is ground, that's the black wire is connected to. It also needs power, so I've got the 5 volt connection from the Arduino is coming over, and that's connected into the power pin of the encoder. And then the other three connections are the three I/O lines. So two of them are for the encoder, the A and the B. They're the green and the orange wires, and then the white one here is connected down to our D2 for our button press. So that's the button. So obviously, if you didn't have a button on your encoder, you wouldn't have that connection. You'd only have the A and the B, the power and the ground. Some encoders don't use power, and sometimes you have to mess about with pull-up resistors to get them to work, but that'll probably depend on the particular encoder and the hardware that you're interfacing it with. So let's run our instrument, and we'll see. This time you can see now, because we've declared two hardware adds, we're getting both of them appearing here. Like I said to you earlier, any hardware adds that you put in there, you'll see them appearing in the hardware tab up here. So this time we've got a rotary encoder because we've added a dial, and it says that it's 8 and 9, and it's given me a clockwise, counterclockwise button, so I can push those to test my code to make sure clockwise and counterclockwise comes up. And the same with the push button for the button button on the end of the shaft. We've just got a button add there, and we tested that like earlier. So you push that, it prints the word encoder button press, which is what we've got here, and then we just try the clockwise. It says clockwise, counterclockwise, and counterclockwise. So let's clear that, run the instrument again, get rid of those, and let's see it actually working with the encoder. So now you can see, if I grab the end of the encoder shaft here and I'm going to rotate it clockwise, we get I've just clicked it one little detent there, so just into the next one, and it's come up with the word clockwise. Now I'm going to rotate it back the other way, so anti-clockwise. So I've gone anti-clockwise now, and it's printed the word counterclockwise. So clockwise, counterclockwise, clockwise, counterclockwise, clockwise, 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 counterclockwise, counterclockwise, counterclockwise. So you can see every time you click that a rotary encoder around one, that 1 or -1 gets returned back to the callback, and you can then act upon that 1 or -1 and determine what you want to do with it. I'm just printing to the console here the words clockwise or counterclockwise, but you could increment the frequency or decrement the frequency if you were using it to control frequency, or whatever you were using it to control. The button, you push the button, encoder button pressed, encoder button pressed, encoder button pressed. And you see the button works the same as the normal little push button that we had earlier. So let's just experiment very quickly with what we've got here. Then we're going to have a little play around with the type. So we'll change that to 2 now. And we'll run our code again. And this time when we click, I'm just going to click it one little detent this time. Oh, you see now it's called that callback twice because it thinks it's a different type of encoder. We've told it it's a type 2 detent per pulse encoder. So it should, if it was a 2 detent per pulse encoder, it would only call the callback once, but because it's not of that type, you get the wrong response. I mean, I suppose you could use that, and you see it does the same in the counterclockwise, does 2 at a time each time. No prizes for guessing what happens when you select 4 in there. Again, I'm only going to move it counterclockwise this time, and you get 4 callbacks clockwise. Same thing. So again, that's expecting 4 detents per pulse type encoder. and if you had one of those in there, it would only actually return one call, or it should only return one callback in there for that type of encoder. So I guess you could use that encode if you wanted to generate extra callbacks for each click. I can't think why you would want to do that. I mean, you could do that in code really anyway, just by looping round twice and running the same thing. So there's not really much benefit to that, but yeah, I suppose you could if you wanted to use it for that particular function. I'm not going to mess about too much with the acceleration, only to say what I've sort of said already, and then you can just play around with that number in terms of it's a bit hard for me to actually rotate this encoder fast and slow there, because I've just got it mounted in a little bit of breadboard there. But if you had it mounted more securely, you could get hold of that encoder and whiz it around a bit faster. You might be able to play and see what happens with that acceleration number as you change it. You'll see the effects, particularly if you use some prints in the console here. You'll get an idea of how many callbacks are getting called as you whiz that encoder around faster, and what effect this number has on how many callbacks you actually get. I'll leave you to experiment with that. The last thing just to say before we end, and that is you sometimes get the dual concentric encoders, the dual shaft ones, the outer and the inner. They work essentially exactly the same as this encoder. A lot of them ones have buttons on them as well, so you can have I say a button, so you can read the button as we have done here, and the two encoders are just treated as two separate encoders, so they each have an A and a B pin that you need to connect up. So for a dual concentric encoder, you'd need 4 connections. You need the 2 for one encoder and another 2 for the other encoder, and then you'd need a 5th connection if it had a push button here. Just mention the dual concentric encoders are just literally treated as 2 separate ones, but obviously they're mounted within the same assembly. I know they're quite popular in the flight sim community for things like radios and such like. Okay, so I think that concludes this video of these hardware items. We'll be covering some of the other hardware items in later videos. Please join me for that. See you again soon. Bye.